Great, thanks, Randy. I think it was S.E.A. first. Is that correct, Kate? I think Wades was going to do second.
Yeah. So I can give Gerd a presentation.
Okay.
Go.
Okay, great. We'll turn it over to Gerd. Thanks so much, Gerd.
Yeah, welcome, and thanks for the opportunity to give a short presentation here to all the members. Yeah, I'll just show you my screen. So in this presentation, I will give you a little bit of overview what we are doing as S.E.A. in the area of V2X, and especially I will focus on our Sniffers, which we have around now since this year, which were introduced on the last Plugfest. And feel free to have any questions after the presentation. So just a brief overview about S.E.A. One or the other might have seen this image before. Now there is a second building on the side. So we are a German system engineering company from our heritage, being on the market since more than 25 years now. We are a small and medium enterprise with 45 plus employees, growing slowly. Since our founding, we were very much related to National Instruments. So we do a lot of our solution based on their portfolio. And we have certain specialties. We are doing a variety of things. So not only V2X, but a lot of other RF applications, but also other test and testbed applications. And very often we are using NI equipment here. And for V2X, we are working in a very close cooperation with NI. For those who know them from the past, they were called National Instruments. Now they are called NI and have a green color, not a blue one anymore. So in the wireless field, as I said, we're doing a lot of different things. A lot of things, especially with software-defined radio. And around 6 years ago, we decided to move into the V2X space, starting with some Fire Mac layer implementations. You will see a timeline, and joining various consortiums. We are a member of Car2Car, which is a European defining group for V2X, especially during the last almost 15 years. We are going to join 5GAA in the future. And beside that, as you see, we are a member of OmniAir, and we also run some research projects with German university in Ingolstadt, for example, which is quite close to Audi. And we also have some cooperation with respect to V2X in the area of autonomous driving. For V2X, we are working globally, so we have a network of partners which are serving global applications in China, in Japan, Singapore, and Vietnam region, in the United States. And beside these close integration partners, we also work with technology partners like NI globally or M3 Systems, which we use to simulate GNSS, which is mandatory, as you know, for CV2X application, but also for scenario-based testing things. Yeah, we also have customers, and one I'm allowed to mention here. And as I mentioned, we started around 5 years, almost 6 years ago, in developing a full portfolio of products. So I don't want to go through each of the milestones here, but what you see mainly is we have some hardware solution for 802.11p. We have the Sniffer solution now on the market since the end of 2020. And beside that, we have developed a lot of system setup and software to do the rest of the testing. So the development of open and closed loop scenario-based and functional testing, as well as scenarios and additional products around that. So I mentioned a broad portfolio. So this also includes various standards which are around. So we are not only working for the US or Europe, but we cover the major standards in Europe, in the US, and in China, as well as still two communication methods, 802.11p and CV2X LTE. And you will see that also in our Sniffers a little bit later on. So the portfolio which we have set up, and that was our goal from the very beginning, was really to cover everything from the real lower physical layers up to the use case layers, and we do that in a very modular approach, modular with respect to the hardware, and that is something where the NI platform, here you see a PXI system, integrated system, which has various modules for RF, for bus communication and measurements. And we combine the hardware to fulfill the needs that we have for specific V2X applications. And we also have a very, very modular software approach, which enables us to combine the different solutions which are required on these different layers from the channel emulation, if you look here on the left side, over measurement and conformance testing, over the mobile applications up to protocol test and conformance testing on that level, as well as function-based testing in open loop and HIL closed loop applications. And finally, we also have implementation of the day one test catalogs ready to run available. Now, these different solutions are used in different application fields, and for sure, we have these different lab setups. But in the field, you need something different, and you see the hardware looks quite different. And we are moving on in the development here, also developing real drive test and logging systems, including the software which is needed to do the evaluation later on. So here you see some of the lab systems. So this is a small test system. Actually, it could even be smaller. This was a show demo for doing the typical protocol level and functional tests on scenario level. So this includes some automotive interface. So here it's CAN bus. It includes the GNSS simulation, and it includes, in this case, the 802.11p or CV2X implementation. And this system could actually be the half size. So it's very, very compact, and it also includes controller and test software and other things. Here on the right side, you see a larger system that is for RF measurements. You see it's the same platform, very different modules. Actually, this system is a superset of this system. Beside doing all this functional and simulation stuff, we can also do all the measurements up to the 26 gigahertz as it is required for the conformance test cases. And here in the background, you see parts of our software. Both systems are based on software-defined radios, which gives us some unique ability, and which we also use in the sniffer. So this is just a brief setup of a RF measurement system. You see it's quite complex at the end, using 3 software-defined radios actually in this setup. And what all this stuff is based on is our software-defined radio implementation. And this gives us the ability, first of all, to run 802.11p DSRC and LTV CV2X on the same hardware components. Beside doing just communication and sending out messages and receiving messages, we can also do the measurements. And we can also do very specific stuff. So one of the specific things is, for example, high performance simulation. So because using the software-defined radio, we can cover up 100% channel load for 802.11 as well as for CV2X. And this puts us in the situation that we can simulate high congestion scenarios very well. Because we have the software-defined radios in actually. Beside that, we can also do very defined replay of simulated or recorded messages, as you will see further down the street. And we have the ability to do very specific fault injection down to the file layer. So really go around any kind of higher layers to simulate certain situations for failure injection, for error detection. And the same is true for TX as well as for RX. So we capture any message which is on the air, which looks like a message. And especially in the test systems, we can also transport it up to the test software level and give good indication what's going on. Now, focusing on the sniffers. We have a roadmap on the sniffer, and what is currently available is a sniffer called 3610, which I will explain a little bit more in detail. And this sniffer supports both communication protocols. It is based on a NI software-defined radio, and it's also based on our integration expertise. I already mentioned it is used, or it can be used in the lab. So OmniAir checked it out for some time in lab testing, but it can also be used for in-field monitoring on the test track. For the logger version of this sniffer, which will be available in Q3, we also have the recording ability, not only for V2X, but also for other things. And the same is true for in-vehicle drive testing, which can then be extended with a software backbone, which gives you many, many evaluation possibilities. In the future, combining mobile networks, so 5G or LTE from the mobile network providers, together with V2X information. So this will be available later this year. Here you see we have a roadmap, and what I'm talking about today is 3610, and you will see some explanation around that. But that is the sniffer version, which provides the ability to run LTE and 802.11p in parallel receiving. And we provide this information to Wireshark as a standard equipment for the evaluation. And it uses this software-defined radio capability. And the very specific thing is we do not only sniff, monitor, and log the V2X messages, but per message we can also provide additional RF parameters and measurements, giving you a good indication what is going on with RF. And this information is also available in the PCAP file then for each message. So how does it work? So basically, the concept is quite simple, as you can imagine. We have LTE RX antenna, 802.11p RX antenna. For special cases, we could change that, but that is a standard setup. We do have GNSS receiver, which we need for LTE for sure, but which also gives us position information. And this RF signals are processed in our software-defined radio domain. RF indications are derived from the signals as well as the messages, and all that is provided by a TZSP data stream to Wireshark. I mentioned the use cases. The whole system, here you see an image of it, is very compact. So the blue box which you're seeing here, this is a software-defined radio on one hand with 2 receiving paths, as well as a complete PC. So it's a standalone box. It has connections for a monitor, for a keyboard, for mouse. If you want to run it standalone, you don't need an additional laptop. But a lot of people have their installation on the laptop, and we can connect to that and just control it by remote desktop. But it is a full standalone system, which can run autonomously. I will move a little bit more in detail. Here you see the more detailed image of it. Looking a little bit more in the details, as I mentioned, we do have the LTE engine running in the software-defined radio as well as 802.11p engine. We have an integrated GNSS receiver, which we are using for timing and position indication. And we do have a Windows running in the box, which you can operate, where you can operate Wireshark with a specific dissector as well as our Sniffer software, which gives you control about the acquisition and also about the current RF situation. As mentioned, there is this remote connectivity by a remote desktop to your own laptop also available, or you run it with additional mouse, keyboard, and other things. So something I mentioned, so I guess everyone from you knows Wireshark quite well. So this is kind of a stupid protocol here that you're just seeing. But the most important point is here in the middle part, which is enlarged and magnified here. So beside the LTEV or the wave messages and the DSRC wave messages, we also provide additional metadata, especially for LTEV about the frame index, the subframe index, PPP values, everything which is part of the S.E.A. 1 layer is made available, which gives a very good idea about what is really going on in the file layer there. This message is available per message so that you can run specific evaluations on that. Beside that, you have full access to the messages as they are decoded by Wireshark. Here you see the main panel to operate it. And on the main panel, you have the different, first of all, you have an overview. That is the operational view here where you see, okay, something is going on by the power spectrum. You see messages coming in by message counters. You see fixed and GNSS coordinate indication. This is the interface, which is the normal operational case. If you're just running it in the field, you want to see what's going on, and which gives us a very basic RF information. In addition, by a connected Wireshark, you immediately see messages going through, but there is more, which we provide. So this is what is available for the operator. If you have administration rights, you can set up the system and so on. But the operator can also see information which is much more in detail about RF. So beside the power spectrum, we have information about the baseband activity, about channel estimation, duplicate image, and about constellation and some other. So subframe timing is available as well. So here's some images are duplicate. But this gives you immediately the idea what is your current RX situation, and that is very interesting in the lab on one hand to really see what's going on. Is there any communication? Is it good quality? And so on. That is something that we see with the test system very often, but also in the field you can see what is the activity in the RF space. Okay, so that is a sniffer. We are working on extending that, and we are looking forward to have that available in Q3, which is a logger, which beside the V2X activity and GNSS also adds CAN bus logging or any other automotive bus to quite similar hardware. We can acquire all that very synchronized, and we can store this data and finally either use it by evaluation from Wireshark or to use it for replay situations in the lab by our test systems. So that will be a superset of the sniffer that I introduced to you. And as I said, that is in work. And this also has some specific feature. If we have the software-defined radio-based system, we are also targeting to record IQ data, not only the message protocol, but also the IQ data for V2X and GNSS. And as you will see in a slide later, we also have the ability to replay the IQ data in our test system so that we really can bring the RF reality as close as possible into the lab. Now, when we talk about logging, we are talking about logging, analysis, visualization, working with the data. For that, we have a full platform, which is called SpaceMaster Geo, which is very scalable. which can combine mobile data and V2X data, and which can give you very detailed analysis based on your situation of driving, of the environment. And we're already working with OEMs that finally use this kind of software as kind of analysis software for drive testing. So that is a very powerful system. If anyone wants to know something about that, please contact me and I'll give you a complete presentation on this as well. So I talked about the recording. If we look into one of our test system, our open loop, so replay-based test system, we have two use cases. One is we have a virtual world. We might have some scenarios and test catalogs. These are executed in a simulator, in a scenario simulator. Here it's CarMaker, which we use standardly, but we can also connect to others. So that is a pure virtual execution of the scenario. We take the simulation data, process it, and once the preparation is done, we have the V2X packet stream over time, the GNSS route over time, and the CAN packet stream, for example. And this data can be used during test execution in our system just for replay and providing this situation to the device under test while monitoring the reactions, while running automated test cases in the back to see if this use case or this situation was handled correctly. Now, talking about the sniffer and making the connection to the sniffer and the logger especially, we have the ability to take message-based recording and to inject it here. So we have the V2X packets, we have the GNSS route, and we have the CAN packets. And we are on this level of having these data streams which can be replayed. And what we are working on is we can have the IQ data recording and we can replay that immediately in the test system so that we go around this packet level, but immediately apply for the RF data, the RF signals to the device under test. That is work in progress. But for that, we can use the same test system for these two different kind of applications. And this virtual path is widely used by tier ones and OEMs now, but we also see a lot of interest in this situation here. The system itself looks quite simple. So it has software-defined radios, controllers, and it communicates to the device under test over the RF interfaces and the bus interface. So that is nothing very complicated. We could implement other things and integrate with other environments that we do at one or the other tier one. Okay. So that was a quite quick presentation. Hopefully it gave you some overview about our activities, especially in the sniffing and logging area, and a very glimpse about what we do with respect to test systems. I didn't touch at all HIL closed loop test systems, which we also provide based on the same hardware and software modules and extended for this purpose. And I only touched our SpaceMaster Geo abilities. So I'm done with my presentation. Are there any questions, any explanation I can give you in addition?
Thank you very much, Gerd. The question is for the data logging. Is that something simple enough to have at the Plugfest? We're out at M-City and can be trying to demonstrate these V2V and V2I apps that might be beneficial to have the recordings of those while we're doing it and help us proceed more into application testing later this year.
Mm-hmm. I think for the V2X data, that is doable. I think we will not provide the CAN interface for the Plugfest, so the connection to the vehicle, but I guess that's not what you're asking for. and GNSS anyhow is contained in the V2X information. So the answer is yes. We focus on the, first of all, the sniffer functionality for sure, but this logging that you just mentioned for the V2X data could be made available. And beside that, we are focusing, as you know, we will start the certification process. We start on this certification with our resources. So I don't want to open another field of activity here.
Okay,
But
thank you very much.
Okay.
And also to mention that their tool is going through some higher volume capturing in some test right now. So like all test tools as far as getting it out in the environment and even higher level volume captures is very beneficial.
Mm-hmm. Are there any other questions?
Gerd, I just wanted to say thank you very much. I thought that was a great presentation. Really exciting to see all the capabilities of your tools.
Excellent presentation. I'll echo those sentiments. Thank you, sir.
Very welcome. And if you have any questions coming up later, just drop me a mail. I'll be happy to answer that. Okay, thanks.
Okay, thank you, Gerd.